Ah man, this machine needs 220 volts and all I got is 120 volt outlets. What am I supposed to do? I got no options here. I can't plug this in. Oh well, that could be a problem anyway. Guess I better fix that. What's up, everybody? My name's Russ with rwgresearch.com, and I've got a very strange problem. Actually, it's probably more common than most of you might think. So I just moved into this place. I have this milling machine here that runs on 220 volts. It does have a three-phase converter, but it's all running on 220 volts, and I don't have a single 220 volt outlet. Now, I could install one if I knew what I was doing. However, the panel is completely full, so I can't even do that. So I'm going to show you today how you can get 220 volts as long as your house is 100, or as long as the incoming line is 220 volts, and I'm on single phase here. So in America, we got 120, 125 volt outlets all over the place. And if you do it right, you can connect two different outlets that are on the opposite phasing to generate your 220 volts. So let me show you how that works. Alright, so before we go ahead and start screwing around with this, first of all, if you do this, it's at your own risk. Second of all, you're going to be connecting things which normally aren't connected in this manner. So just be aware, this works, but ideally install a 220 volt outlet. But for me, I know what I'm doing, so I know this is going to work. Now, the first thing you need to understand is how the system is set up. So you have the line coming in from the telephone pole or from the power pole. There's a transformer here converting higher voltage down to a lower voltage. So this is 220 volts, and this area right here is your breaker box. Okay? And your breaker box has got two lines coming in. This is 120 volts and this is 120 volts. And so if you look at the phasing, all right, if this is the sine wave, I know it's a poor sine wave. All right, if you have another one, it would look like this. So the zero line is here, like that. So this is your maximum voltage and your maximum negative and your maximum positive. So what you're looking at, and then your ground is going to be somewhere in here. So what you're looking at is you've got 240 volts AC across these two lines. So conventionally, they tie one of these phases to the small prong on your outlet, and the big prong on your outlet goes over here to neutral, which is actually tied to ground inside your breaker box. And so you measure from this point to this point, and you'll get 120 volts. If you measure from this point to ground, you'll also measure 120 volts. So this is one outlet, and this is going to be another outlet. Now, as long as these two outlets are on the opposite phasing, okay, so if you measure from, in this case, this will be ground or neutral, okay, and if you measure from here, let's say here to here, you're going to measure 125 volts. But if you were to measure from here to here, you will measure 240 volts. Okay, so what we're actually doing is we're grabbing the hots coming in, which is where you normally connect your 220 volts, into an outlet, right? So if we had, can you see way down here? I guess you can, but if we had another outlet down here, all right, the big O 220, they would be connected to the lines just like this. All right, so if I measured from here to here, so from neutral to a hot, I get 120. If I measure from neutral to hot on the other side, I get 120. However, if I connect across the two phases, I'm going to get 240. All right, and that's due to this out of phasing. So what we're going to do is we're going to take a meter and we're going to go around and we're going to meter outlets in the shop here and find two of them that when I connect the small prongs, I get 240 volts, and then I know that those two are out of phase in the panel. Now what you got to be careful about is there is, okay, a breaker here. And these breakers, if this one is 10 amps, all right, and this one is 15 amps, then you got to be careful because you got these on different amp ratings. You'll probably be okay. However, it's best to find and make sure they're on the same amp rating. That's pretty difficult to do, but we'll move forward and go try to meter some outlets. All right, because I know that this outlet is tied to the same power source, I'm going to go ahead and plug these two in, okay? And we're going to get roughly 125 volts AC on the meter here. Okay, now if I go from the hot to the hot, I should basically get 0 volts, which I do. That's because those two outlets are tied to the same thing and they're in phase. So now let's try to find two different outlets in the shop that give us 240 volts when we plug them both into the hot. Alright, so I've got my meter set on AC still, and I've got this outlet right here, and I've also got this outlet over here. So I'm not sure if you can see that, or if you can see that I'm even plugged in. But here I have 247 volts, so 240 volts. Alright, so there it is, 247. It's a little high, but that's okay. It's 240 volts. It always fluctuates a little. We've got this thing plugged into the hot of this outlet and the hot of that outlet. So we know that we've got 140 volts across those two. So we're going to go ahead and make up our wiring. Alright, so for the side of the mill, in my case, this equipment is a milling machine, I am going to be using just the cord that I've got already wired, and I know how these are wired. Black and white are the two hot, and ground is my neutral or my ground. So for this, I'm going to use one of these. Alright, this is a, what is that, 20 amp? That's a 20 amp, okay, 240 volt, 250 volt max. Alright, this is a 6-20P, and it has just a backing on it like this. And what I'm going to do is I'm going to connect these two prongs right here are going to be my hot, and then ground. Okay. Now if I ever move to a place that has an actual outlet, I can put an outlet in like this. This prong at an angle actually represents the 240 volt orientation. So go ahead and wire this one up. Now when we wire these two up, what we're going to be able to do is connect either one of these to either side we want. And we definitely don't want the high voltage or the line side to be connected to these two prongs going into our wall outlets, because then we have exposed power at all times. So make sure you put the female side on the side being plugged into your wall outlet. Alright, so there we've got these wired up. Now I know what the color code is of this wire. You might also have a red wire instead of the white wire, but in my case I have a black, a white, and a green. So in my case I know the green is ground, and I know the white and the black are my hots. It really doesn't matter which one you connect these to because they're across the phasing of the hots. Let's go ahead and close this up, and then we'll do the other one. Alright, so for the other side that I'm going to be plugging into the wall, because I don't have too much distance between the two, I actually have these power cords right here. These are standard power cords that you find for a computer, and the reason I'm going to use these is because I know they're rated. Alright, if I look really closely, these are rated for 15 amps, alright, at the right voltage. Alright, 125 volts, because from here into our main plug we got 125 volts on each line. So we're actually going to be using these so that I have factory ends. Then I'm going to cut off these plugs and use a very similar style plug for the other side. Alright, this is the male. Sorry, this is the male. This is the female. Do you see why they're called male and female? Yeah, some people never could figure that out. So these guys meet together. And this is going to be how I'm going to be connecting this, so everything's tucked inside of here. Originally I was going to put everything in a box and then actually connect a standard plug for a computer, and I can just plug these two things in and then plug the other side of the cord in, and that would be kind of something I could do. But instead, I found these, so I'm going to use them. Let's wire these up. Now, if you're not sure which wire goes to which prong, you can take your ohm meter or your continuity meter and you can check and make sure you get the right prong connected, because if you get the wrong wire connected, this won't work. So we've got the meter on continuity, and I'm just going to go ahead and pick the big prong, which I know is this side, and I'm going to check these wires. Alright, so the brown one, in my case, is the hot. I will go ahead and check the other one, just to make sure both these are the same wiring scheme, because I have two different cords, and they are. So in this case, the prong that goes to the neutral, which is the one that is the bigger side, we are actually not going to use it at all. So I'm going to cut it off completely. We're only going to be using the ground. So the two hots go to the two hots, and we'll tie both the grounds to the ground, just so they're tied together. Now in my case, I'm not too concerned about cutting the neutral wire short and just leaving it there. However, you could put some electrical tape around there if you're concerned. So there's the prongs, and there's the plug. We have a hot, and we have our two grounds on the ground. So we'll go ahead and get this closed up. This is a tight fit. Get this closed up, and we'll check it before we plug anything into it. There we go. Finished. So, alright, so there we go. We're all plugged in. We have our two outlets, or two prong plug. What are these called? Oh yeah, these are males. We got the two male ends that are going to go in the wall. We got that plugged into the female, okay? So this is our adapter. And then we've got our 220 volt plug here that goes to our single into there. Now what we're going to do first, before we plug anything in, we're going to go ahead and test this, okay? So we'll go ahead and plug this guy in. And we'll go ahead and plug this guy in. Okay, so if I did everything right, we should have the right voltage. Let's go ahead and check it with our meter. Now, in case you accidentally get the wrong wires, it shouldn't hurt anything, because you're just going to be, you know, neutralizing things, because it's just going to be connected to 120 volts instead. So, I don't know if you can see that, 240 volts. So we're good. So now, I'm going to go ahead and plug the machine in. I don't think it's turned on. We're about to find out. Ah, I did it. Let's go see if it runs. So there it is, plugged into the two outlets. Now let's go over here and hope that everything works. I got the milling machine off. Oh well, I don't know what that means. Let's find out. Alright, so I forgot. It's been a while since I plugged this in and used it. There's a button on the back, and that starts up this right here. This is actually a motor that is connected to the right stuff, and this generates our third phase. So let's turn this on, hit this button, and we're running. Alright, this thing makes a lot of racket. Let's see if it works. Cool. That's really exciting. This thing's pretty cool. It's got a really cool gearbox on it. You just turn this and it slows it down or speeds it up. Awesome. Cool. I can finally use this thing. Sure does make a lot of racket though, doesn't it? The whole thing kind of vibrates like crazy with that 3-phase converter on there. Alright, well that is how you take a I don't have a 220 volt outlet and sort of create one without modifying anything in your house. Now if you do this, you do it at your own risk. I know what I'm doing, so if you don't feel comfortable, find somebody that is comfortable and let them do it. Yes. Now it's time to cut some stuff, which I'm not going to do in this video. Thanks for watching. God bless. Read the Bible more, and I'll see you later. Woohoo!